let's look at solving rational equations. So what do we mean by a rational equation? Well, equation that you have fractional expressions in. So let's say we have x over x minus 3 plus 4 over x minus 4 equals x over x minus 4. It is 2x. All right. So, what I want to do here is, first off, I want to figure out what's the least common denominator. And what I'm going to look at is all these denominators, and the least common denominator is going to be the one that covers all of these. So it has all the factors that show up. So if I look at this first one, there's nothing to factor here, so this x minus 3 is the factor. It's got to have an x minus 3 in it. And then I look at the second one, and again, there's nothing to factor on the bottom here. So x minus 4 is its factor, so it's got the least common denominator has to have an x minus 4 in it. And then I come over here, and I say, okay, well, I got x minus 4. I already got that, so I don't need to add another one in. So this is going to be my least common denominator. This is the smallest denominator that would cover all of these fractions. Now, before I go on, I might want to go ahead and say there's a few values here that will not work as answers. You know, I don't know exactly what the answers are yet. I haven't worked the problem out, but I know something is, there's a couple of numbers that are not going to work. And those numbers are 3. 3 is not going to work. And 4. 4 is not going to work because 3 would make this x minus 3 0. So remember that came from this. That means you'd be divided by 0. So you cannot divide by 0 ever. So 3 is not a legitimate answer for this problem. Likewise, 4 would make this x minus 4 and this one 0. And you can't divide by 0. So for the same reason, 4 is not a legitimate answer. Now that may not be a problem when we work out the thing, but if we get either of these as answers, that particular answer will not work. So let's go about how we're going to solve this. Now that I know the least common denominators, there's a couple of different approaches. The way I generally do it here is I end up multiplying both sides of my equation by this common denominator over 1. So what I'm going to do here is I'm going to multiply everybody by x minus 3 times x minus 4 over 1. X minus 3 times x minus 4 over 1. X minus 3 times x minus 4 over 1. So that goes back to the rule that as long as you multiply both sides of the equation by the same thing, it's a legitimate way to go through the process of solving this. So what happens here is the part that matches, notice I had an x minus 3 initially on the denominator, that's canceling out, and I'm left with the part I didn't have. I didn't have the x minus 4, and now that's what I'm going to be left with here. Same thing on this second one, I had an x minus 4 already, now that gets canceled out, I'm left with the x minus 3, and the same thing over here. So let's see what we get. We get 2x times x minus 4, and we get 4 times x minus 3, and we get x times x minus 3. And now we're going to work this out. 2x squared minus 8x plus 4x minus 12 equals x squared minus 3x. And, maybe clean this up a little bit. 2x squared, negative 8x, positive 4x is a negative 4x minus 12. X squared minus 3x. Get it equal to 0, we got a quadratic equation, so we're going to get it equal to 0, so subtract that x squared and add this 3x. Alright, and so you get x squared minus x minus 12 equals 0. And I want to solve that problem. So, you can quadratic formula or something, but it'll factor. This will factor as x minus 4, x plus 3 equals 0. So set each of those equal to 0, solve them. So add 4. So x equals 4. Subtract 3. So x equals negative 3. Now, those may be the correct answers, but remember we have that issue where in the original problem we had fractions and we couldn't divide by 0. And so if I look at these answers, I got 4. 4 minus 3 is 1. That's okay. 4 minus 4 is, uh-oh, that's 0. That does not work. So this 4 value does not work as a solution. So we'll call it an extraneous solution. And then x equals negative 3. So negative 3 minus 3 is negative 6. That's okay. Negative 3 minus 4 is negative 7. That's also a negative 7. So that's okay. So these are the answers. So on these problems, you kind of have to check your answers. Make sure you're not ending up dividing by 0. With polynomial equations, you don't have to check them. You can. There's nothing wrong with checking your answers. But you're not going to run into a situation where you do all the math correctly and you get an answer that shows up that just doesn't belong. Here we did all the math correctly, and we just got an answer that is not a legitimate answer, and that can happen when you have these fractional expressions. So let's do one more of these, just kind of practice up. So let's say I want to solve here, and I have 2 over x squared minus 4 plus 1 over x squared minus 4x plus 4 equals 3 over x plus 2. Okay? It's like, all right, I want to figure out what the least common denominator is here. So first thing I need to do is I need to factor all these denominators. So this is the difference of squares, x minus 2, x plus 2. This one, x minus 2 times another x minus 2, so x minus 2 squared. And then this one is just x plus 2. So my least common denominator would need an x minus 2. It would need an x plus 2. So those are the factors that show up here. And I come over here and this says I need an x minus 2. And you know, well, I already got an x minus 2. Well, I need an x minus 2 squared. All right, so while this has an x minus 2 already, I do need it to be squared because I have to cover not only the factors, but the multiplicity of them as well. So I need a square on this x minus 2. And then x plus 2 I already have covered, and it's to the first power. So not only each factor, but also the number of times it ever shows up. I have to have at least that. So I'm going to multiply everybody by that over 1. And I'm going to distribute that through. And just like before, what we're going to see is the part I already have is going to cancel out, and I'm going to be left with the part I don't have. So I'm going to have, after I do that multiplication, I'm going to have 2 times one of the x minus 2's is going to cancel out, the x plus 2 is going to cancel out, and so that's going to leave me one of the x minus 2's. Plus 1 times, well, both x minus 2's will cancel out, and I'll have x plus 2 equals 3 times, in this case, the x plus 2 cancels out, and I'm going to get both x minus 2's there. So I'm actually going to write x squared minus 4x plus 4 just to save myself a step to distribute, since I already know that's what that is multiplied out. But the part I've already got on the bottom is going to cancel out here, and I'm going to be left over with whatever I have. So 2x minus 4, x plus 2 equals 3x squared minus 12x plus 12. And again, I got an x squared, so I need to get this equal to 0. First, maybe I'll clean this left side up before I start moving things over. So subtract 3x, add 2, plus 14. Now this might factor, it might not. I'm not going to spend a lot of time trying to worry about it. I'm just going to use the quadratic formula here and just rewrite that problem. 3x squared minus 15x plus 14. So quadratic formula, negative 15 plus or minus square root of negative 15, negative b. 4 times a is 3 times 14 all over 2 times a is 3. So negative 15 is positive 15 plus or minus. This is a 6, square root of 225, and then 12 times 14, so 15. Okay, so 225 minus 12 times 14, 168. So subtract those, you get square root of 57, which I think 3 goes into there, but 19 times. So that's not going to break down. So this answer is x equals 15 plus or minus the square root of 57 over 6. Those are our two solutions to this problem. Now, do I have to worry about those dividing by 0? Now, that's always something I have to consider. But if I go back and I look at the original problem, and I remember we found out the denominators, we factored these out, and we said, okay, well, what makes these 0? Well, what makes this 0 is positive 2, so x can't be that. And what makes that 0 is negative 2, x can't be that. So, you know, clearly we didn't get either of those as our answer since we got some irrational numbers here. So we're okay. These are the answers. But that's something you always, anytime you're dealing with rational expressions, you always, or in equations, you always have to consider what happens if you might divide by 0.